basic SQL. Okay. Last time we stopped at this point, domain or creating domain. Before that, let's just take review. We speak about or we spoke already about creating table. So this is a keyword to create table, then table name. Then we can start to name the attributes of this. Sorry, the sound on? Yes, okay. So we can start to name the attributes of this table and the data type and some constraint like not null, or if we leave it, this means it allow null value like your primary key and other constraint and default value. We will speak about the not null and default value later. Okay, we can create domain as you can consider it as a new data type for us. We can use this domain for any attribute. Imagine that we have database and we have many attributes for names of employees, for example, names for departments, name for projects, name for, and I need all the names to be standard with the same data type and some specification or some constraint like not null and extra things we can put it. So instead of repeating this with all attribute with the same domain, same data type, same size, and same maybe some constraint, we can create domain and use the name of this domain. So this make it easier to create or define our attributes, or even change some constraints and things about attributes. And even this improves readability of the schema, because we usually name the domain with readable name. For example, if I need to create domain for names, I can use name, for example, name type for SSN. It's our example here, SSN or social security number. If you see here in our database, our example database, we have SSN in this table. We have SSN in this table. We have SSN in this table. Okay. All related to each other. Yes, so all should be from the same type and same size, because foreign key and the primary key should be from the same size and data type. So if I define each one data type and each one size, for example, I could make some mistake here. For example, I defined SSN here. This one, character size 10. Hello. Okay. If I defined it here, character size 9, this will cause a problem because this foreign key should be same size with primary key. But what's the solution? I could create domain like this. Where is it? Domain, name it, for example, SSN type, as you can use as or without as. It's similar, okay? You can remove this as. This is the name of the domain. This is the keyword, create domain. I think I have to change the batteries for my mouse. Just wait a minute. Okay, wait just a minute. Seems it's better to use wired mouse, not wireless mouse. Okay. Then almost with everything we use create table, create domain. Okay. Then create what? Create domain. This is the name of the domain. This is the name of the domain. Then each domain have name, and this name should be unique, of course. And this is a keyword, create name. Then I can put many things like data type, like for example, you just leave space and you can put constraint like not null. You can leave another space and put constraint like default. I'm not sure about the spelling here. For example, default one. Then semicolon. Semicolon means the end of this statement. So you can define many things. Even later we will see constraint. You can define constraint also with this domain. Okay, so after that, you can use this domain instead of data type. So instead of, if I define domain for SSN, instead of this, all this, I can change with the new domain. We can try this one on PG. I think it's here. No, not here. Which one? Okay, this one. We can use here. You can simply, you should be inside any database. Then you can write a click in the query tool and write your query to create domain. For example, I want to create domain. Okay. Let's name it anything. Names domain, for example, or names type. Okay, then, for example, var character 30, I need all names to be from type var character 30, for example, and not null, for example. Okay, what else? I can put default, but of course this not have meaning here to have default for the names. For example, some attributes I need default value. For example, department number, I can make a default value for employee. When I create employee, to get the default value for department to be number 1. This means each employee, if I did not give the value, it will be department 1, for example. But I don't want to put here. Here, you can see in the schema something called domains here in pgadmin, okay? It's different from one DBMS to another DBMS, what's the way to work here, but about the query, it's same query. So instead of click and create domain and use like forms, you can use like this. But in our course, we depend only on queries. Okay, so just okay, query done successfully. You can just make refresh. Now we have here names type as domain. Now, if you want to create table, and of course you can, later we will see something we call alter, a change. You can change any things using alter any constraint or any attribute. We will create table now. Create table, anything, XY. Okay, now we can start to create attribute. For example, ID as integer. Okay, primary key. Now I'm creating table named at XY. Then I have attribute. Let me name it XY ID from type integer, and it's a primary key. I want to create name. Then now I can use varchar 30 or something like this, or I can use the domain that I created already. So you can use like this, varchar 30, and it should be not null. For example, anything else, default value and anything else. Okay. Or instead of writing all this with every table, because I mentioned here the data type for the name, I need it standard for all tables. So I can use names. What's the constraint here? Names type. Sorry, names type. This is the domain that I created here. names type. Okay. So now if you check here, let me refresh the tables. We have table, new table, XY, have XY ID as integer and its primary key, and name from this domain that I already created. So if we check here the properties, you can see here columns. Here data type, name, type. Okay, which is the domain that I created. If you want to insert data now, and you did not put data for the name, it will reject. Why? Because as you can see in the domain, I mentioned that it's could not be null. This is a query history. This one, create domain. Where is it? Okay, the domain, the sentence create domain, name type, and I put that it's varchar 30 and not null. Because we did not take until now the insert, we can use just the click to insert here. Okay, insert into XY, and this attributes. Later we will take this insert statement. If I want to insert here, for example, for the ID, and I ignore the name, it should not allow me. Why? Because name, we said that it's not null. It cannot be null. Domain name type does not allow null values. So this is not working. Why not working? Because we did not enter values for name. We can enter values for name. Okay. Execute query. Okay, we use this one. Okay, it's successfully. We use for the string here single colon, not double. Okay, single, not double quotation, single quotation. Sorry. That's all. Now, if you want to get information, you can use select statement. We will see it later. Okay, this is about domain. Then domain, it's like we are creating our data type, and we can use it instead of any data type. For this data type or domain that we can create, we give name, we give any information for the attribute data, like the data type, size, some constraint like not null, like default. I think default this one A. Okay, so I can control the constraint. Before that, if you remember, we already spoke about when we spoke about relational model. I think chapter 4 or 5, something like this. We spoke about constraint, key constraints, entity integrity constraint, and referential integrity constraint. Key constraint, we can define it by defining the primary key. Integrity constraint, it's from the DBMS itself. When you define key, it could not be null. So DBMS should force here the entity integrity constraint. Referential integrity constraint, that's a foreign key here. Entity integrity, that the primary key cannot be null. If you define any attribute as a primary key, DBMS will not allow you to insert null value. Same thing for referential integrity constraint. The foreign key value must have value already in the primary key, or it should be null if null allowable. For example, here, if in department number here, this foreign key, and it's originally primary key in the department. Okay. Here we mentioned that it's not null. So if you want to insert a project information, you should insert value in D number. You should insert, cannot be null because you already put constraint not null. And this value should be available in the department D number here. Why? Because the department D number is the primary key of that foreign key. Primary key. Okay, this is about constraint. It's your job here just to define the primary key and define the referential integrity or the reference for the foreign key. Then the DBMS will enforce this 3 constraints. We can define constraints for the attributes. We have many types of constraints, like default value. The sentence for it, just after the attribute name, you can put, or at the same line for the attribute name, you can put the default, then you give default value. Okay, now here, if we create another table, create table RR anything, okay, and we have now okay, RID integer as a primary key, and we have, for example, name varchar 20, the size of this string 20, and default single Ahmed. It's not reasonable, but just for example, okay? So now this means if you did not enter the name, when you insert values, it will take this initial value. And not null. Okay. Okay, now we have a new table, RR, with this specification. Let's insert information for this table. Okay, I will insert only information for ID. I mentioned that name not null. Yes. When I create the table, I think this query. When I create the table, I mentioned that it could not be null, the name. Okay, let's execute this. It's working. But the name not null, I said. I did not enter data for the name. Why it's working now? It's working because there is a default value. When I did not enter the name, it will take the default value. So if you check here, if you check the data, let me write it. Okay, later we will take it, inshallah. But let me now write it as a query. Select all data from RR. Okay. From RR. Okay, then you see the data. The RID 5 and name Ahmed. From where take it? From this one, default value. Actually, this important attribute default, especially when we speak about foreign key, because foreign key cause most problem when you make operation like update or delete. Foreign key cause problem. Usually, if this foreign key, if you remove the primary key and there is a value in the foreign key, then what will happen with this value? It will be deleted with the primary key, or it will be changed. We can define all this thing. Later we will see the importance of default, especially with default value, especially with the foreign key. Okay, then this is the default value. If we did not enter the value, it will be taken. Null and not null, already I mentioned it. You can define any attribute to reject null value. If you did not give this attribute, this constraint, not null, the default null. Okay, another thing, you can make a check for the value. For example, defining attribute D number, integer, not null. We can use keyword check to check the entered value to be in specific domain or in a specific range or specific values, or to check the value it's correct or not correct according to our criteria. For example, if we need to restrict the number for D number to be between 1 and 20, I can write it in two ways. Check, this means when insert this value, the DBMS itself will check the value according to my definition for the database. Take D number more than 0 and it's Boolean condition here. You can use many ways to check. Here, because it's integer value, I used Boolean condition to check if this one bigger than 0, or always that check have Boolean condition. But I mean here, I used to check with integer values, and D number less than 20. I can use less than or equal 20 or less than 21. Another way I can use with check D number between, it's another keyword, between 1 and 20. So I can write it like this, number more than 0 and D number less than 21, or I can use it check D number between 1 and 20. So it's also a Boolean condition. If true, the check, then it will allow inserting the data. If false, it will disallow this insertion for the data. So until now, we take default, null and not null, and check. All this attribute constraints means I can write it after, like this here, after the name, when I create table, after the name of the attribute. For example, bname varchar 15, not null. I can make also default value, and I can make a check here. Before this colon or comma, I can make a check also. Sorry. Check. Okay. About the primary key, we already saw the primary key clause. Clauses mean sentence, or how to use the keyword inside your sentence. We have two ways. We can define the keyword, the primary key, in the same line with the attribute itself, like this, D number integer primary key, or at the end of the table creation, you can write primary key and open practice, and if you have more than one key, you can name all the keys. Okay, so here we define two primary key. Let's see. I think here you can see that we defined the primary key in separate line. Here also, we have two primary key for this table. Okay, if I don't want to put it here in separate line, I can define it directly with the attribute ESSN character blah primary key. Primary key like this. But we have two primary key. Yes, you can. Okay, dependent name here. Also same. Primary key. So now it will know that we have two attributes as the primary key. So I can write it like this at the same line with the attribute or in separate attribute. Okay, where is it? Unique. It's same as the way of a primary key. Unique, this means this value, for example, if D name unique, this means there it should not allow two department name with the same name or the same value. So when you mention that it's unique, this means cannot repeat it inside the table. So if we have table here, there is no row with the same D name according to this one. D name cannot be repeated. So if you have D name X, you cannot have another D name X. This means of unique. So it's same like primary key. Primary key cannot repeat it. It should be unique. Then any attribute you make it unique, it's like a candidate key or secondary key. We said that table could have more than one key, and we choose one of them as primary key. The others, we called it candidate key or secondary key. This is a way to create candidate key when you make it unique. Okay, it's doesn't have any issue with the key constraint or entity integrity constraint, but here this value will not be repeated inside and cannot be null, of course, because null value also repeated. You can use two ways, like the primary key, in the same line with the attribute, or in separate line, you can make unique and define the attribute that should be, or attributes that should be unique. Okay, foreign key clause, same as primary key clause, but here you should name the attribute as foreign key and what is the reference for it, what's the primary key for it. Like here, you can see foreign key, ESSN, and reference. So defining foreign key have these keywords: foreign key, then the name of the attribute here inside our table as a foreign key, reference inside another table, the primary key. Okay, so reference, employee, SSN, this is the primary key that this foreign key reference to it, and this one the foreign key. Okay, so to define the primary key is a foreign key, you have to mention the attribute that should be foreign key and the name of its parent primary key. Of course, if you have more than foreign key, each one in separate line like this. Okay, now most problem happens when you try to make operation with tables that have foreign key. Like if you have delete or update operation. So any operation or attribute update operation will be rejected if it's have violation for this referential integrity constraints or foreign key constraints. What type of this problem? When you try, for example, if you have, I need the database itself here. Let me, what we have here, project dependent. Okay, let's speak about department, location, and department. Here, this foreign key, and here it's original primary key. If we are trying to delete department number 4, here in the parent, table, we want to delete this one. This one cause violation for the referential integrity. Why? Because I'm trying to delete this one primary key, and here there's a foreign key. So if this one okay and this one deleted, then this foreign key do not have parent, the primary key. So DBMS will not allow this operation. What's the solution? The solution, I can give some constraint here. Where is it? Sorry, I have to move up and down to see the examples. I can attach or add for when defines a foreign key, I can give some action to be done here, like set null. This with the foreign key, not with the primary key, like set null, cascade, or set default. Cascade, this means if we have two tables like this, and we have X here, and this X is primary key. Okay. For example, we have 5, 2, and we have here 5, 5, 2, 1, should be 1 here also. Okay, now if I mention when defining this one foreign key, if I mention that it's cascaded, this means when I delete the primary key, it will be deleted from here also. The foreign key will be deleted. So this is the meaning of cascade. This means one operation will cause another operations. I did only as user one operation, deleted this primary key, but cascade means it will go for the foreign key and delete it. Actually, in delete, we don't usually use cascade. Usually with update, we use cascade because it's very dangerous to make cascade with delete because, for example, delete one department will cause deleting all the projects and all the employees for this department. So we usually use it with update or sometimes with update. So mean of update cascade, this means if I change this department number of this X to, for example, 10, all X5 that change to 10 will be changed here inside the foreign key. This is the mean of cascade. Set null, it's very obvious. It's if I delete, for example, this primary key 2, so each foreign key here will change to null. Set default. Set default, this means if I use set default option with on update or on delete, then if the parent or the primary key updated or deleted, the related value here from the foreign key will be set to its default value. And where I define the default value, when I define this attribute, I make default value. Let's see this operations here. Okay, we define constraint, primary key, and foreign key. Yeah, primary key and foreign key. Here with the foreign key, we mention on delete, what will we do? So it's keyword on delete. On update, what should be done also. Okay, here we mentioned that on delete, set null. On update, cascaded. So this one for table employee, and we speak about super SSN. And SSN, it's from the table itself. SSN as the primary key, and super SSN, it's also in the same table. It's not here. Not all the definition here. SSN, SSN, and super SSN. I think you should be familiar with this database. The whole semester we speak about this database. This means if we update the value of SSN for the manager or supervisor, all its value with the employees will be changed to the new value. On delete, set null, this means if I delete employee number 5 and there's some employees that super SSN number for them 5, it will be set to null. Another maybe this because it's recursion here, it's not clear. We can see another example between two tables, like here, foreign key, D number, this one, inside employee table, reference to department number inside this foreign key, and it's referenced here inside department table, which is D number. Okay, and we set this constraint. On delete, set default. On update, cascade. This means if we have department number 5 and we update it to 8, then we will go to each D and O that have value 5 and we update it to 8. So if update the primary key, this will cause update because cascaded on update. This will cause update all the foreign key with the same value to the new value. Okay, what about on delete, set default? For on delete, set default. This means if the primary key deleted, for example, department number 5, go to the foreign key here, D number, and if it's 5, we will set default to its default. This means we should specify default here for the foreign key. So the foreign key D number have default 1. So if this one deleted and we have some tables have foreign key with the same value, it will be changed to its default. What its default? Its default when we create the table said that it's 1. So this same as where you said if any department deleted or the employee will shift it to department number 1. So we make the default value department number 1. What if I try to delete department number 1? What will happen? I need answer from you.
We couldn't delete this default.
It will be rejected.
Yes.
Yes, you're correct. It will be rejected. Why? Because it's default. It will be rejected when? Not always. It will be rejected if there is a values here. Okay, focus. If I have table here and I have D number, okay, and D numbers 5, 3, 2. Now, if I want to delete department number 1, it will be okay. Then when it will be rejected, it will be rejected if I try to delete and we have department number 1. Another case to reject it, okay, if I already don't have department number 1, I already deleted it. Now try to delete department number 5. If like this, in department number, I have 5, 3, 2. I don't have department number 1, and I'm trying to delete department number 5. Now it will be rejected. Why? Because when we try to set default for this foreign key, we will change this one to 1. But if you look here, D number 1 not existed in primary key, so it will be rejected. Even delete 5 here, it will be rejected if we don't have the default value in the primary key. So it's depend. When we try, any operation will be rejected, when we try to delete value, that will cause set default, and this default value not exist. So default value not exist for this foreign key. I mean the reference value in the primary key not exist, then this operation or even any other operation for deleting a primary key from department number will be rejected if department number 1 not existed. Okay, I think it's clear now. So another thing, we can, each constraint, we can give it a name, a unique name, using constraint keyword. Why I could give name like this here. Here constraint primary key, I give it a name. If you see here, we have this comma and we have constraint keyword and we give name for the constraint, any name you want. There is no comma and this one's a constraint. This means for the primary key constraint here, we give name EMP PK or primary key. It's any name, you can choose name, but it's better to choose. Why I could do like this? Because later, anytime you can change this primary key, you can change this constraint, okay? Anytime. So this constraint for the foreign key, I could change it later. Maybe after a while I said, okay, I don't want on delete to be set null. I need on delete to be set default. After you creating database and start using it, you said I want to change it. To change it, if you did not have constraint name like this, it's cannot be. So when I create constraint like foreign key, primary key, or any other constraint, I can use name for it. Later, anytime you can use something, we called it alter or change, alter or change. For example, alter foreign key, okay, or alter constraint name, set on delete, set null, or something like this. We will take the alter later to how to change any constraint. But the issue here, each constraint I can give it a name like this to be able to change it later. Okay. How long we have been here? Okay. Okay, last thing before the break. We already mentioned it, that check clause. Okay, we can use that check to during the create table to check the values for the attributes. We already saw it here, I think. Here, check clause. Okay, check the values of this attribute, key number, and we see some examples. We can use that check separately also. here at the end of the table, before the comma, you can make the check for the attribute. A check, for example, D number, okay, between X and Y, between blah blah, anything for a check. Okay, here another example. I can check, for example, here, manager start date should be more than department create date. If you return to our database, a company database, you will not find department create date. It's just, for example, imagine that we have attribute with department table called department create date. So it's reasonable that manager start date should be after department creation date, cannot be before. So to check this value, we can use this check statement after or at any part from the create table. So you can have like this, create table X, and you have attributes. Then here, anywhere you can make a check that X, for example, attribute X value or attribute XY should be bigger than attribute XZ value, for example. Any Boolean condition you can use to check values. This means when we try to insert data, the manager start date should be bigger or should be after the department create date. So it's just condition for inserting or updating data. Okay, after the break, we will speak about the basic retrieval queries in SQL. We have break for 5 minutes only.
Okay, Doctor.
Assalamu alaikum again.
وعليكم السلام ورحمة الله.
عليكم السلام.
Okay, we continue.
وعليكم السلام.
Retrieval queries or basic retrieval queries. We already saw in relational algebra. We did not take relational calculus because same ideas. We stopped with relational algebra only. Relational algebra, we take the select and the project, and we take the join and the operation set like union, intersect, even Cartesian product. Actually, I mentioned it before last time, but another time, some of you used union and intersect, but in the wrong way, because as we mentioned many times, union and intersect, okay, the relation, two sides should be type compatible, we will see how to apply those things using SQL or retrieval queries. All our retrieval queries use statement, we called it select statement. So you will see each retrieval query will start with select keyword. Okay, this to get information from the database, we use the select statement. The information that retrieved from the database, it could have identical values, not like relational algebra. When we spoke about relational algebra, we said that relational algebra operation and even relational calculus use the set operation and set theory. That's why in the result it's not allow identical values, two tables with the same value or two-way row with the same value. Yes, this just was with relational algebra. With a select statement in the SQL, you could have two or more tables or row with identical, the same value for the attributes. That's why, unlike relational model, it's not using set theory. It uses set theory, but it have some what we said, not everything depending on the set theory. That's why we name the result here usually multi-set. It have sometimes repeated or identical rows, or bag. It's like bag. You can put many things with same values. Okay, it's just information. Now, the basic form for select statement: select keyword, then attribute list. This is the attributes that we need it, or we need to retrieve it information, or its information. Like if I said find the names of employees, so select name. If name 3 parts like database, then select first F name, mid name, and L name. Or find the salary for all the employees, then select salary and extra. So this is the list of attributes that I need its value. From this list for list of tables that I need to get the value from it. It could be more than one table. This means I will get value from more than one table, or I am connecting, joining here, or make condition between two or more tables. With examples, it will be more clear. Where this means a condition for this information. For example, I need employees with first name Ali. Then select first name, last name from table. From which table? From employee, where first name equal Ali. So it have condition to retrieve this information or this values. This condition, it will be Boolean expression or conditional expression. So it will use comparison like equal, not like C double equal, equal, less than, or equal, greater than, or equal and not equal. In some language, you can use this one or this one. Okay, in SQL, we use this bigger than with less than. This means not equal. Okay. So as I mentioned, we have selection and we have projection. Yes, in the relational algebra. Selections, this means the attributes name here. The projections, this means the attributes that or this condition. So this equivalent to selection from the relational algebra, and this one equivalent to project or projection from relational algebra. The list of attributes and that we want to drive, and this one's a Boolean condition for this attributes. Just some examples. In this example, retrieve or find the birth date and address of, before completing, we need birth date and address. Then select birth date and address of the employees whose name is John B. Smith. So we have only one table to get the data from it for employees. So select birth date, address from employee, from this table. Where, what's the condition? First name, John, middle name, B, last name, Smith. And we can connect between condition using and or using or. Of course, the different, you know, between and or. But usually we don't use or, we use and. It's very rare to find retrieval query using or condition. Okay. So another query, retrieve name and address. Names, this mean first name, last name, mid name, or first name, last name, in short. First name, last name, and address of all employees. Okay, from employee who work for the research department. So works for which department? Research department. So we need data from department. Then select first name, last name, address. Yes, it's from employee, but here we are using information also from department. That's why from employee, comma, department. Where? This is a condition. How to know that this employee work for research department? First, we need to connect between employee and department. We should have, I think, the database. Let me bring the database here. Okay. Where is it? Okay, I think we can find it in, I forget where okay. Okay, I can do it myself now here. From our I think at the beginning of this chapter. No. Relational model. Okay. I'm trying to bring the database so we have the data in front of us. Not ER, I think this one. Company database. I forget where I put it. It's not the one that I need it here. I think we have it around this area. I have it usually in separate file, but I don't know. I forget where I put it.
Doctor, I sent it
Here.
a message.
Okay.
Maybe this?
Okay. This
Or,
one. Okay.
Oh.
Already found it. Okay. Here. Here, retrieve name and address. Name and address, it's from employee. Of all employees who work for research department. as you can see here, this department, we have the research department. So it's where in the department, and we need the names. It's from where? It's from employee. So we need to connect between these two tables to check the name of the department, then we can retrieve the names of the employee. How to connect between them? This foreign key and this primary key. So we have to check that department number equal department number inside the employee equal department number inside the department, and department name should be research. So we have two conditions. First condition, that the department name should be research and D number from department equal D number from employee. Here I don't have a problem because we have different names. What if I have the same name, D number and D number inside department and employee? Here, select statement will not understand if you have D number equal, and imagine that D number inside an employee also same thing, D number. In this case, you have to mention the table name here before the attribute. If you have two attributes with the same name. Here in this example, let's see example here. In this example, imagine that we have this one to connect between department and employee with the same D number, as I mentioned for you. In this case, if we have two attributes or more with the same name in different relation, of course, in different relation, you cannot have two attributes with the same name in the same relation. Each attribute should be uniquely identified by name. But you could have same attribute name in different relation or in different tables. When you see relations, this means tables. Okay, so if inside employee I have D number same like D number with department, then I can use the whole name of attribute like this, or shortcut name. We will see how to use it later. Okay, so I have to mention here that this D number belongs to department. This D number belongs to employee. This same example like before. Like this example, but with assumptions that same D number. We have same D number. Okay, another query for every project. For every project. So we need to get data from project located in Stafford. List the project number. Okay, we need the project number. The controlling department number. We need D number. Okay, it's also inside the project D number. Yes. And department manager last name. Department manager last name. Okay, wait. Department manager come from where? come from the department. Here you can see department manager. It's the SSN of the employee who managed this department. So also this foreign key. So I need the name of this SSN or this manager. So it's connected to employee. So we have information from employee, we have information from department, and we have information from a project. We need the department connected to, or the project connected to this department, and department connected to the employees that manage this department. So we have project, department, employee. This to connect between department and project. This to connect between department and its manager. This the manager, number of the employee, and this the employees that have the same SSN number. This means that manage this department. And this is the condition for the location of the project location. Okay, then I need L name. This come from employee. Address, this come from employee. This birth date come from employee. D number come from project. B number come from project. Okay, all data come from project and employee, but I need department to connect the condition here. This condition to connect between project and department, and this condition to connect between employees that manage this department. Okay, it's like this. You can make analysis for this type of by the way, it's much easier than okay, I already sent the files, all the files. Much easier than relational algebra even, because here the join directly with the where clause. But we have join, okay, a statement. We will speak about join statement. We have join statement inside SQL, and it's very famous to use join statement with SQL. Okay. Another way, we said if we have same name, attribute with the same name, then we can use the name of the table to differentiate between this two names. Okay, if we have different name, it's okay. We can ignore the table name, or we can use the table name. It's okay. Everything will be correct here. If the compiler or if the DBMS understand, because this not repeated name, it will understand it come from employee because it's not in department. D number, it will not understand if we have D number also in department and employees. That's why we can use the table name. Another way, we can use aliasing or renaming. We can rename the attribute, or we can rename the table. Rename in this retrieval query, not renaming in the database itself, okay? Just in the retrieval query. So in the retrieved information you are renaming. It will not affect the original data inside the database, okay? Here example for renaming, we can rename like this from employee as E. You can even use here from department or employee as E, department as D. Then you can use D dot D number, E dot D number. Okay, so you can rename use as like this, employee as E, employee as S. Why we use this, especially with this type of a query? Because here we have recursion. We have employee and another employee. In this example, for each employee, retrieve employee's first name, last name, and the first last name of his supervisor. If you check here. Okay. This is the employee. We define employee by SSN, yes. And its supervisor, we defined it by super SSN. So imagine we want to retrieve this employee and its supervisor. So this information comes from employee, for the employee, and his supervisor, for example, 3355, this one here. So this supervisor also his employee and his information here. How to know? By searching this super SSN with SSN. So we are connecting the table with itself. This is the foreign key and the primary key in the same table. So we need to differentiate between the super key and the the primary key and the foreign key. So we will give the one with the primary key, which is the employee itself. We will name it E, and the other copy we will name it S. So we need to retrieve last name, first name for E, which is the employee itself, and last name, first name for S, which is the supervisor, when we have SSN and equal super SSN. Okay, then like this, because we have two copies from the same table, we name first copy E, second copy S, which is for the super. We need first name and last name from E. So E dot first name, E dot. That's why we cannot use employee itself, employee dot first name, because both table actually employee. That's why we need here. We have to use here the alias name, E and S. So first name, last name for S, where the supervisor number here. This is the supervisor, and this one, its number to retrieve its first name and last name. So where employee number equal employee supervisor number equal SSN number. Like this, we connect the recursion. In recursion, we have to use the alias name. In different things like this, different retrieval queries, we can also use alias number. Another thing, this as it could be eliminated. You can just use like this, employee E without as. This one. You can write it like this. Employee E and employee S. You can continue. Without as, it's okay for most TBMS. Okay, you can also rename the attributes. Here, in the same thing, employee as E, you can open practice and rename all the attribute. Then, employee as E, FN, ME, LN, SS. Okay, just here we renamed the attributes. Of course, it will be taken as when you create the table in the same order. When you create the table, if you put first name, then this one means renaming first name to FN, and so on. Another thing, you can even rename anything anywhere in the select statement. You can rename here E FNAME as N. This means in the result, you will not have FNAME like this, you will have N. Let's use this query and see all the examples on it. To make the time shorten, I will only copy and paste, then we can make the changes. Okay, we will use this query. Select E, FNAME, E, LNAME, S. Okay, same query now. Okay, then we have first name, last name, and first name, last name. This first name, last name for the employee E, but you see we have same FNAME, LNAME. We want to differentiate. I can differentiate like this as employee name. E name or E first name, and this one as E last name, and this one as employee supervisor, super. Okay, first name, and this one as employee super L name. Okay, then I renamed them. Now we have employee first name, employee, okay, L name. I put the 3, I don't know from where come. Okay, employee super first name, employee super. It's good for my query to have different name in this case, because we have F name, L name, F name, L name. I want to know this one, which F name, which L name. So I can rename using as. Okay, so I renamed using as here. I can rename any column. Not necessarily all columns. I can rename any column. Just any column like this. If you want to rename any column, just select after the column name, you can write as and your alias name. Okay. About where clause, we can eliminate it. If we do not have where clause, this means retrieve everything without any condition. So this one, select SSN from employee. This means retrieve all the number of the employees or the SSN for the employees. What if I have more than one table? It will make a cross product, Cartesian product or a cross product, as we saw in the relational algebra. What's the meaning of a cross product? This means if I have here, I am retrieving as number and department name. If I have, for example, here SSN number 1 and 2, and I have department name X and Y, this select query, select SSN and the number, make Cartesian product. Cartesian product between employee and department. This means take each value from here with all values from here. So the result will be like this. SSN and the name, and it's don't have any meaning actually. Without for loop making Cartesian, without where clause making Cartesian product like this, do not have any meaning, because you bring employee with all department name, not his department name. So this will brought like this: 1 with X, 1 with Y, 2 with X, each value from the first one with all values from the second table, 2 with Y. Of course, if you have more than one attribute from this table and more than one attribute, this means the whole related attribute here with every related attribute from here. You could have more information here, like for example, location, L and M. It will be repeated like this: L, M, L, N. Okay, because X now with M, same value come from the same table. The Cartesian product between the tuples from employee and the tuples from department. But we have here specific attributes for each tuple. Okay. About the asterisk or star, you can use it to retrieve all the attributes. So if I said I need all the employee from department 5, all employee information. I did not mention I need the name or I need the address. I said retrieve the information or retrieve the data of the employees who working in department number 5. Then all the attributes we use only star. It's not even logically to use select first name, last name, mid name, address, blah, blah, blah. If you retrieve everything, we use only star. Okay. Even if you use the star and you have from 2 tables, this means all attributes from employee and all attributes from department that applied this condition. And what about this one? Query 10A. What's the result? Yes.
It is two tables for employee and department.
Yes. But we don't have where clause here. If we have where clause, then it will take information from employee and department that applies this condition, then connect between them depending on condition. But here we don't have where clause. What the result will be? Cartesian product between employee and department. This means here, for example, this means I will take this row join with all department in the result. Then I will take this Frank with all the departments. Doesn't matter if he connected to the department or not, because I did not put where clause. Take all the information for Alisa, all the information, because we used star with all the information of research department, of administration department, and of the headquarters department. So repeat all the rows here with all the rows here, Cartesian product, because we don't have where clause. If we have where clause, we will take the all the attributes, but not Cartesian product that depend on this condition. Then we connect this one like join, this one like Cartesian product. Okay, this one join without using selection, and this Cartesian product without using selection. This is the different. Okay, we still have too many things. Even 2 hours not enough. I give 2 hours and not enough. Okay, we will stop here and we continue inshallah next week.
Okay, doctor. Thank you.
Okay, then.
Okay, doctor, thank you.
That's all for today. See you inshallah next week.
Lecture, please, doctor.
What?
Can you upload this lecture today?
It's already.
Okay.
You can't. Let me check. I think I already uploaded it. Let me. Where's our Telegram?
Yes, doctor, we get it yesterday. Or before yesterday, we get it.
Here. Okay, this one.
Yes, thank you.
Chapter
Thank you.
6. It's already from last week to this week. And this database, and this even BCNF example. Okay. See you inshallah next week. Have a nice week and
thank you very much.
Assalamu alaikum.
Thank you very much, doctor.